Bismillah ar-Rahman ar-Rahim. Today we will try to illustrate how we can determine the acceleration by using free fall ball. Actually, at first, our purpose today to determine the acceleration of the free fall ball. Okay, what is the free fall ball? Here I have mass, the iron, okay, and string. The mass of this iron, it's N. Here I have the string. The difference between these two masses is huge. I mean between the string mass and this iron mass, it's huge because that we can ignore the string mass. Okay, we have this the holder and the clamp. Okay, here. What I mean by using free fall ball, I mean this simple pendulum, it's connected with or from one point here from the top, and from here it's freely moving from any point to point according to what the force is acted on it. Here, this is the free fall ball, this motion, okay? Just two forces are acted on this motion. The first one, the frictional force of air. Second one is the gravitational force. By that, when this body lost its kinetic energy, will be at this point. This point's name is the equilibrium point. The gravitational force is very clear because this mass is stopped at this point according to the gravitational force. By that, what I mean by free fall ball, this mass moving freely without any other forces except the frictional force and gravitational force. By take this body to few with small theta, 10 or 15, not more, to keep this pendulum to be simple pendulum. When I leave it, we'll go and back to the same point. Go and back to the same point. Throwing from the equilibrium point, when this body lost its kinetic energy, will stay at this equilibrium point according to the gravitational force. What is the oscillation? Oscillation, that's mean when I take this body here, go and come back to the same point. That's mean this mass has one oscillation. What is the time period? The time period is the necessary time to this body to give opportunity to this body to go and come back to the same point. This is the time period. What is the frequency? The frequency is how much times this body will do some oscillations. For example, when I say this frequency is 10 or 20, this mass will go and back to 10 or 20 oscillations. This is the frequency. But at first, let me talk about the length of this simple pendulum. For example, here I will work on it when this length will be 15 centimeter. Here, like that. For example, it's 15. I will take this mass to simple angle, not more than 10 or 15. It's one oscillation. The time period to this mass. We'll calculate by using a stopwatch. All I need, the length and what is the square of the time period to each length. I will work on 15 string length, 25, 45, 65, and at last will be the longest is the 85. Actually, when it's 15, the time period will be smaller than when the length is increased or enlarged more. Let me show you. The same angle, but with longer distance. That means the time period will increase when the length is increased, okay? When I have in my column the length of this string and the square time period, the length will be at x-axis, the time square will be at y-axis. Here, theoretically, the relation between them will be linear direct relation. By that, I can calculate the slope. But before all of this, let me explain something related with the accuracy. What is the accuracy? The accuracy is the depending on standard result. What is the standard result of the acceleration? It's 9.8 meter divided on second square. That will be our academic, our standard result. We will try to reach this number. This according to the frequency. What about the precision? All of these have the same goal to minimize the mistakes as possible. Here, I say we need just one oscillation and the time square to this one oscillation at this length. To apply the precision, we will do that not just to one time, to one frequency. The frequency will be 10 or 20, 15. It's not standard or constant number. Here we will work on frequency to 10 oscillation, not just one. That means I will calculate by my meter scale. To make this, it's 15 centimeters. The same angle by using this ruler. Here, it's 0. Now it's 15. I will take 10 oscillations and calculate the time to it. And after that, I will do that again to calculate the average between these two times. Like I said, it's the frequency was to 10 oscillations. That means to calculate the time average to one oscillation, I need to divide the number on 10 to can reach the time to one oscillation at this length. And after that, I can multiply it to can reach the t square. Okay? And the same thing with 25, the same angle, the frequency to 10. I will do that 2 times. According to the precision, T1 and T2 to the same frequency should be near from each other. To be sure I'm working or my experiment goes with the right way. Okay? It's not should to be the difference between my measurements to be too much. Okay? After that, 45, 65, and at last will be 85. After that, I will work on the acceleration according to the gravitational force equal 4 pi squared divided on the slope. By that, when I calculate the slope between the t square with second square and the L, I will have a line, linear relation between them. Slope will be, the result of slope will be here. You can calculate the acceleration of this free fall ball. All the numbers and the diagram will be in next video.